All right, hello everyone. So today we're doing a video. This is the second part of a video on improper integrals using the convergence test. So does the integral from 1 to infinity of 3 plus sine of x, x to the 1/5 minus 1/4 converge or diverge is our question here. Okay, so quantity 3 plus sine x over quantity x to the 1/5 minus 1/4. And yeah, as I said, we're going to use the comparison test. And the comparison test as follows. If you have 0 less than or equal to f of x less than or equal to g of x, basically you have two functions that are positive. One is larger than the other on some interval going from a to infinity. If a to infinity g of x dx converges, then a to infinity f of x dx converges. If a to infinity f of x dx diverges, then a to infinity g of x dx diverges. So basically, if the bigger one converges, then the smaller one converges as well, and if the smaller one diverges, the bigger one will diverge as well. Okay, so how do I deal with that situation here? So let's, first of all, let me copy the function here. And let's work, we have to work with an inequality essentially here. Now, what I see here is, key thing here to look at is if you look at your denominator, it's got a subtraction in it between the terms. You're subtracting the terms. And there's a rule basically that says if you, that fraction, a fraction with the same numerator, but a smaller denominator will be bigger than a fraction with the same numerator and a larger denominator. So what I'm getting at is this. This right here would be true. 3 plus sine x over x to the 1/5 is less than or equal to 3 plus sine x over x to the 1/5 minus 1/4. Yeah, this numerator is smaller than that one, but overall the fraction is going to be larger. Yeah, and this is just like saying 1/5 is less than 1/4. 4 is the smaller of the denominators, but because you have the same numerators, the 1/4 is actually larger than 1/5. That's what's going on here. And what I'm going to do is I'm going to make another inequality. Okay, when you're working with this rule, you want to work with the most simplified function as possible here. And sometimes you need to make up a list of inequalities like we're doing here. So 3 plus sine x, the smallest sine can be is -1. So all of this would be right here. That would be greater than or equal to 2 over x to the 1/5. And that's a function that you want to work with. Eventually, you have to do a integral here, an improper integral. Yeah, the point of the comparison test in so many words is that you don't want to actually, this was the original, I don't want to work with that. I don't want to integrate it because it's almost impossible to integrate with techniques that we have. So I'd rather work with something simpler that would give me the same results in terms of a convergence or divergence. So that's what this whole test is about. So I'm going to go ahead and integrate this. So limit as b goes to infinity. So I'm going to rewrite this in the notation that we often use for an improper integral. And we will go ahead and integrate, and you would get x to the 4/5 times 5/2, I'm not mistaken here. Or it comes down, yes, looks good. And then we're going to plug in our b and our 1 in here. So 5/2 b to the 4/5 minus 5/2 1 to the 4/5. And then we're going to take this limit as b goes to infinity. So we are going to get infinity here. So your integral diverges. And therefore, by the comparison test, so does the other one you were comparing to. So 1 to infinity of 2 plus 3 plus sine x, my apologies here, 3 plus sine x over x to the 1/5 minus 1/4 is going to diverge. Okay, nice. All right, so that's that's an example with a divergent series. Okay, so if you haven't checked out part one, go ahead and do so. We talk about how an example that converges instead. Okay, thank you for your time.